Hello, it's Ben again. Anyway, yeah, YouTube cut me off again. Again. It's very frustrating. But anyway, moving on with my problems. When YouTube and webcam failing to work, tempted to do some very vulgar signs, but I'll keep it civil, guys. Alright, so let's continue where I was at. Alright, let's follow up with light. Alright, you're moving at the speed of light. You're going as fast as you can. That's a constant, that's a known. We have that variable set up, okay? Next, we have gravity, pull of gravity. Well, my reason, what's the heaviest known mass in the universe? Neutron mass! Okay, so neutron mass is, as far as I know, I'd have to look it up. Double check, which I think for what it is basically the heaviest mass, because essentially all the neutrons are compacted together and formed into a solid mass, because most of us, we're all made of space, pretty much. And if you don't know that, and if you're really curious, look up atomic function and how it works, and the way the atomic setup, okay? Because it's chemistry, okay? High school chemistry. You will understand my mind. That's a scary thing, isn't it? Alright, moving on, let's get to the most important part of the video that I was getting into, and where YouTube messed me up. Alright. This is my equation. Ta-da! Right. Well, it needs some work. It needs a lot of work. A lot of work. Okay? But this side of the equation, I reason, is correct. Now, PTS means perceived time scale. And then perceived, or PTP, that's a little p, perceived time pass. So, this means essentially, all this equation out here links up to PTS. Okay, sounds like an STD, doesn't it? Alright. You can figure it out. So these are the whole set. Alright. Now this side is the one that's giving me the problem. Big problem is not necessarily with speed of light, because speed of light, that's pretty easy. You know, if you could figure out perceived time pass, or PTS, perceived time passed, whatever, just by speed of light, physicists already figured out. Yeah, but to try and get the whole thing, you have to factor in gravity. You have to factor in some gravity on how gravity affects it. So I reasoned neutron mass, heaviest mass. That's constant. Now you have to figure out the volume. What scale do you set the volume at? You know, how does neutron masses? How do you basically get your time where no time is, you're doing nothing, no chemical reaction, because you're underneath so much gravity, and to what volume, to what extent does that occur? And that's what's throwing me off here. But otherwise, I'm missing some parts I need to add to this equation. But basically, this is light speed. There's an S there. It's rather dinky there. This one's also light speed, which I need to affect this equation because this equation is off. I need to cancel out some variables I reasoned in there. And this is known speed, Ks, and then neutron mass, which I need to cancel out here, and then Nm is our neutron mass, and then known mass. And then all this, what I had, which I need to fix, I need to figure out how to fix it, because it's blowing my mind out of proportion. Ugh. Yes, I'm crazy, okay? It was all being all this, once it was figured out, once it was all added together, was being multiplied by light speed over known volume and neutron mass, or multiplied by neutron mass. Now, I don't think this is entirely right. I need to do a lot of work on that equation, but I'm trying to figure out how to take gravity and the heaviest form of gravity out there, heaviest form, and put it in a scaled down form to basically get your perceived time scale. Now, I don't know whether I said this experiment was on the air video. I don't know. I'd have to remember. But one experiment I said that I could have for figuring out gravity and how that affects time in comparative to 1 hour is you take two things of separate masses, you put them in space with no velocity affecting them, none whatsoever, and then you take readings on which clock. Essentially, it's like a stopwatch. One has a weight attached to it, one does not. With no direction affecting it. It just sits there in space with nothing on it, nothing affecting it. Yeah, that's an odd way of going about it. How would you get that to work? Basically, you take a nuclear clock, you just drop it out there, you figure out how it works, or how fast it takes, and the way that it takes, and then compare it to the other one that was not moving, just saying that one had weight, one was constant. One had less weight. You figure it out that way. That was the experiment I had. Now, how do you get for no directional movement? A lot of calculations, and I really don't want to do that much calculation, nor do I have a spaceship, so I'm not going to do it. Just an experiment I've had, an idea I've had. I'll see, maybe they'll do it. Maybe they'll do like an experiment like that in 20 years. Shit, I don't know. Damn, I cussed. Alright, anyway, I should probably stop before my frustration gets a hold of me and my insanity leaks into your brain. Anyway, peace out, guys, alright? Hopefully YouTube doesn't cut me off again, because then I'd be mad. Because then it'll be part 3. Peace.